Welcome all for this video lecture session on topic holography. Method of recording optical images. Holography means complete recording of images through light wave. The wave parameter recording is of two ways. One is amplitude and the other is phase components. This technique was proposed by Gaber, 1949. He did not have laser when he formulated holography. The process does not record the image of the object, but records the reflected light wave, and the record is hologram. For the first time, the laser hologram were prepared by Leith and Opatniks in 1964. Holography is a technique that captures light scattered from an object and then presents it in a way that appears three-dimensional. This is achieved through the use of coherent light sources and interference patterns. The coherent source is nothing but which emit a light wave having same frequency, wavelength and in the same phase, or they have a constant phase difference. We need coherent light to create interference patterns. Where interference is a phenomenon in which two coherent waves are combined by adding their intensities with consideration of phase difference. Here we see an image gets recorded. A coherent light from laser is directed on beam splitter. A beam splitter divides it into two identical beams as object and reference beam. The object beam get reflected by surface of object onto the plate, where the reference beam directly falls onto the plate. Now hologram gets recorded. To capture 3D image, the film stores the amplitude and phase of light. Recorded interference pattern produce more information about the focused image. The laser light hologram can be reconstructed by using the same laser light as for recording. In reconstruction of hologram, the object beam and reference beam strike the hologram plate from opposite sides. To prevent external light from interfering, holograms are usually taken in darkness or in low-level light of a different color from the laser light making the hologram. Light source for holographic applications is a laser for a number of characteristics: coherence length, power density, wavelength stability, wavelength range. There are different methods for creating the holographic recording, but the laser is often the principal source of coherent light. Since the image creation is based on the phase difference between the two light paths caused by the object of the study, any phase difference, non-coherence, caused by the laser through operation, will either destroy the resolution or severely reduce the available depth of field of the final image. The coherence length, narrow line width, of the laser is a key characteristic. Like standard photography, the creation of an image needs exposure time. This exposure time is dependent on the sensitivity of the recording media and the amount of light that is available. As the source of light for holography is the laser, higher power outputs offer shorter exposure times and/or larger fields of view. Let's move on to the applications. How holography is used in various fields such as security, cloud data storage, teaching, interferometry, military, and in medicine, etc. Holography can be utilized for testing and measurement through interferometry. The technique has been used to measure vibrational amplitudes and deformation in a number of objects, including biological specimens. Material testing can be easily done with this. The object gets illuminated by a source having two separate frequencies. However, the image is reconstructed with a source having single frequency. In this case, each illuminating frequency produces independent and separate hologram. When the recording is illuminated, it generates two separate wave fields, which interface. Holographic interferometry can be successfully used for the following purposes: real-time monitoring of deformations, testing of thin material bonded on the surface, detection of cracks and breaks in materials, testing of real objects against standard objects, represented by computer-generated holograms. Now let's see the applications one by one. In data storage, Holographic storage is computer storage that uses lasers to store computer-generated data in 3 dimensions. Holographic storage systems are a rewritable, high-density, high-speed optical information storage medium. Holographic storage is capable of recording and reading data from the storage medium in parallel. Big data analysis. Cloud storage providers. Data warehousing are some the data storage by holography. Holography creates secure identification features, such as holograms on banknotes, passports, and ID cards. These holographic security features are difficult to counterfeit, enhancing security and preventing forgery. In medical imaging, there is a requirement of imaging of internal and external human body parts. There are digital imaging technologies which provide 2-dimensional and even 3D images of body parts. It helps to improve the way of procedure and treatment, provide advanced imaging, effective learning, useful for multiple images, capacity of storing, do not require any projection screen, store, preserve, and archive information. Here are the advantages and disadvantages. Advantages: cost-effective, high storage capacity, increased feasibility of object depth, 360-degree view of image. Disadvantages: limited to thin transmission holograms, provide static images, high production costs. Thank you.